Good morning to all of you, students. Today is 14 April 2023. We'll cover the topic chemical reaction and equation on behalf of Silicon Classes. Kindly note the email ID siliconclasses24@gmail.com. If any queries on this particular topic or any other topic, you should send a mail. All the mails will be replied immediately. So हम लोग आज केमिकल रिएक्शन एंड इक्वेशन को कवर करेंगे इस सेशन में. इट इज वेरी मच यूजफुल एंड वेरी इंपॉर्टेंट टॉपिक्स. दिस टॉपिक्स इज ये टॉपिक सीबीएसई में भी है, आईसीएसई में भी है एंड अदर डिफरेंट स्टेट बोर्ड में भी है. सो दिस टॉपिक इज वेरी इंपॉर्टेंट in our day-to-day life also and for examination purpose also. So now we'll start the topic of chemical reaction and equation. Here the topics to be covered: number 1, definition; number 2, writing of chemical equation; number 3, balance of chemical equation; number 4, types of chemical equation. There are mainly 5 types of chemical equation. 1, A combination; B decomposition; C displacement; D double displacement and D oxidation and reduction. So ये जो 5 टाइप ऑफ केमिकल इक्वेशन है, ये हम लोग 1 by 1 इस स्लाइड में हम शो करेंगे एंड विल डिस्कस. So these are the main. These 5 are the main type of chemical equation. And after that, we will also discuss the effect of oxidation and reduction, that is corrosion and acidity. These are the main 2 topics, main 2 effects which will we are being shown in our environment. Corrosion and acidity. So first of all, we should go for the definition. The definition of chemical reaction. A chemical reaction is the process of breaking. A chemical reaction is the process of breaking of chemical bond in one or more substances and the reforming of new bonds to create new substances. So chemical reaction क्या है? Chemical reaction है breaking of chemical bond, means bond को break करके एक नया bond create करना and so a नया compound form होना. So this is a simple definition. Breaking of chemical bond in one or more substances and reforming of new bonds to create new substances. It is a chemical change, not physical change, in which matter changes into a new substance or new substances. Here, in the left-hand side, we are mentioning the reactant. One or more reactant will react with each other to form a new compound, which is called the products. So, the properties of product are totally different from the reactants. For this reason, we are telling that the chemical reaction is nothing but the chemical changes. Chemical changes. Okay. So chemical changes by the product which is formed through a chemical changes is a totally different properties from the reactant. Now, we are coming from some example how to write a chemical equation in a chemical changes. So number 1, magnesium reacts with oxygen to form magnesium oxide. Here the reactants are magnesium and oxygen, which will react with each other to form a magnesium oxide. The properties of magnesium oxide is totally different with respect to magnesium and oxide. Another example is calcium hydroxide react with nitric acid, form calcium nitrate and water. Here, calcium hydroxide and nitric acid are the reactants and calcium nitrate and water are the products. The properties of calcium nitrate is totally different from calcium hydroxide and nitric acid. Water is also a different property. So, whatever we have discussed in earlier slide, that this is a chemical change. In a chemical change, the products will be formed in a different properties. The properties of the product will be different. प्रोडक्ट का जो प्रॉपर्टी है वो टोटली डिफरेंट होगा आपका रिएक्टेंट का प्रॉपर्टी के साथ. So there will be no similarity of the properties for product and reactant. How to write a chemical equation? The reactant should be mentioned in the left hand side of the chemical equation, and it should be separated by plus. The reactant को हम लोग लेफ्ट साइड में लिखेंगे and two or more reactants should be separated by plus side. Similarly, we should write the product in the right side of the reaction and right side of the chemical equation, and this should be the two or more different products should be separated by the positive side. Here we have shown some example you should see. Next, we should write, there are so many examples for chemical equation or chemical reaction. Suppose magnesium plus oxygen. It will form magnesium oxide. Here magnesium and oxygen are the reactants and magnesium oxide is a product. The properties of magnesium oxide should be totally different from magnesium and oxygen. We should write another example, right? It's like H2 plus O2. You should know the hydrogen gas and oxygen gas. These two gases are well in our environment. It will react to form the most precious water. Hydrogen is a gas, oxygen is a gas. It will react to form H2, that is liquid. Okay. So the properties of water is totally different from hydrogen and oxygen. Even the state has been changed. Hydrogen is gas. Again, I am saying hydrogen is a gas, oxygen is a gas, and these two will react with each other to form water, which is a liquid. So these are the this is the very important example of the chemical equation, where water will form, it is a different property and even it is a different state with respect to the reactant by which it is formed, that is hydrogen and oxygen. So these are the example of the chemical equation, and there are various examples we should discuss in due course of time. Next, these are the characteristics of chemical reaction. If a chemical reaction will be happen, there may be change of color. Number two, evolution of gas. Precipitate may be formed. Evolution or absorption of heat during a chemical reaction. So these are the main characteristics in which if a reactant will react with each other and product will be formed, then there are mainly the product may be a different color from the reactant. The gas may be evolved during the reaction. Precipitate may be formed during the chemical reaction, or the heat may be absorbed or evolved during a chemical reaction. So these are the characteristics of the chemical reactions. Next, now it is a very important topic, how to balance a chemical reaction. All of you know, as per law of conservation of energy, the total mass of the element present in the products of a chemical reaction has to be equal to the total mass of the element present in the reaction. Again, I am saying the total mass of the element present in the products of a chemical reaction has to be equal to the total mass of the element present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. What it is saying? Suppose iron is participating in a chemical reaction. In reactant, there should be iron. In product, there should be a iron, but in a different type, different compound. But in both reactant and product, the number of atoms of iron should be same. The element or the compound or the whatever be the element present in the reactant and in the product should be same. And in specific terms, the atoms, suppose iron atom, oxygen atom, hydrogen atom, if they will participate in a particular reaction, in reactant and product, the atoms of particular element, particular compound participating in the reactant, participating in the reaction in the reactant side should be same in the product side also. For that reason, we should balance a chemical reaction. Suppose here we take an example. Here iron Fe reacts with water, form Fe3O4 ferrous oxide and hydrogen. Here we should see that in reactant side there is one iron atom, but in product side there should be there are 3 iron atoms. So it is not following the law of conservation of energy. That is, the number of atoms of ions are different in reactant and product. So this should not be happen. So we should balance the chemical reaction so that in reactant, whatever the iron atoms are there, in product, there should be the same number of iron atoms. It should be applicable in all elements. So we should balance our chemical reaction positively, otherwise it will be against the law of conservation of energy and it will be wrong. Now, we should show the step-by-step balancing of chemical reaction. Number 1. First, draw boxes around each formula. Here, iron and water are the reactant and ferrous oxide and hydrogen are the products. We should draw a box on both the reactant and both the products like that. All of you are seeing in the slide. Next, list the number of atoms of different elements present in the unbalanced equation. There are 3 types of 3 elements: iron, hydrogen and oxygen. Number of atoms in the reactant: in iron there is 1, in product there are 3. Hydrogen in reactant 2 atoms are there, in products 2 atoms are there. Oxygen 1 atom in reactant and 4 atoms are in product. So we should balance iron, oxygen and hydrogen has already been balanced. It is often convenient. We should start the balancing, but it is often convenient to start balancing with the compound that contains maximum number of atoms. हम लोग पहले वो एटम लेके स्टार्ट करेंगे जो एटम मैक्सिमम है, आइदर इन रिएक्टेंट और इन प्रोडक्ट. यूजिंग द ए क्राइटेरिया को मद्देनजर रखते हुए हम लोग Fe3O4 को सिलेक्ट किया, वेयर द एलिमेंट ऑक्सीजन इन इट. ऑक्सीजन एलिमेंट सबसे ज्यादा है Fe3O4 compound में जो है 4. So we should select initially for oxygen atom. First of all, we should balance the oxygen atom in both reactant as well as product. So we should draw a table. Atoms of oxygen, whatever in present in reactant or in product. Initially, oxygen present in water in reactant side, that is 1, and in product side Fe3O4, that is 4. So we to balance the oxygen atom in reactant and product, we should multiply 4 in reactant so that the oxygen atom become 4 in reactant side and it will be equal to the product side as in Fe3O4. So we should multiply water by 4. Here we have seen iron, water is multiplied by 4 and the other compounded elements are remain same. Next, Fe and hydrogen atoms are still not balanced. So we should take the hydrogen atoms. In step 3, by considering the step 3, what is the hydrogen atoms in reactant? What are the number of hydrogen atoms in reactants is 8, which is mentioned in the table. In products, it is 2. So in products, to balance the hydrogen atom in between reactant and product, we should multiply 2 in product so that in product side it should be 8 and in reactant side it should be 8. So in partially balanced equation, we should multiply 4 in product side by hydrogen. We should multiply hydrogen by 4 in product side. It is now it is showing here. Next, now we should balance the iron atoms. Still the iron atom is left to be balanced. Still the iron atom is left to be balanced. In reactant, iron atom is 1. In product, iron atom is 3. So we should multiply the reactant by 3. That is, iron should be multiplied by 3 and products, it is already showing 3. Now this is the balanced equation, that is 3Fe plus 4H2 arrow Fe3O4 plus 4H2. We have already discussed that the reactant and product should be separated by arrow and this arrowhead should be indicated the product. Finally, we have to check the correctness of the balanced equation. We count atoms of each element on both sides of equation. The number of atoms of element on both sides should be equal. So this equation is now balanced. Whatever the method we have adapted to balance this particular equation is called the heat and trial method. So by this method, we may balance any of the equations. Now, we are coming the types of chemical equation types, very important. We have already discussed in our initial slide that there are 5 types of chemical reaction. 1 combination, 2 decomposition, 3 displacement, 4 double displacement, 5 oxidation and reduction. Now, we are coming the combination reaction. What is the definition of combination reaction? A chemical reaction in which 2 or more elements or compounds reacts to form one new compound. Again, I am saying a chemical reaction in which 2 or more elements or compounds react to form one new compound. Here, we are taking the example of calcium oxide and water. Calcium oxide, that is quicklime, reacts with water form calcium hydroxide, and heat will be evolved in this particular reaction. We have already discussed there are mainly 4 types of characteristics of chemical reaction. One of that, heat may be evolved during any chemical reaction. So in this reaction, heat has been evolved. Here, calcium oxide reacts with water to form calcium hydroxide. It is nothing but the example of a combination reaction. Here, calcium oxide combined with water to form calcium hydroxide, that is Fleckert-Lime. That is single. 2 reactants combined with each other to form a single compound, that is calcium hydroxide. We should take another example. Suppose H2R, H2 plus O2. It will react with each other to form water. हाइड्रोजन एंड ऑक्सीजन रिएक्ट करके कंबाइन होके फॉर्म कर रहे वाटर दैट इज लिक्विड. We have already discussed it. There are so many examples of the combination reaction. We have already discussed the magnesium plus oxygen. It will form the magnesium oxide, single compound. Magnesium combined with oxygen to form a single compound, that is magnesium oxide. These are the 2 examples of the combination reaction. Next, we are coming a very important reaction, that is decomposition reaction. What is the definition of decomposition reaction? A chemical reaction in which a chemical compound decomposes into 2 or more simpler substances. A chemical compound decomposes into 2 or more simpler substances. Mainly the decomposition reaction will take place as a thermal decomposition, which will governed by the heat, and another one photochemical decomposition, which will be governed by the light. Here we are taking an example of the thermal decomposition reaction, which is governed by the heat, that is ferrous sulfate solid. If the ferrous sulfate solid will be heated, it will form ferric oxide, which is solid in nature, sulfur dioxide and sulfur dioxide. Sulfur dioxide and sulfur dioxide are both gaseous in nature. So this is the example of thermal decomposition reaction. Another example we are taking for photochemical decomposition. Here, silver chloride in presence of sunlight form silver and chlorine. Here actually the formula of Cl is there Cl2. By mistake it is 2 true, they should be in subscribe. So silver chloride will decompose in presence of sunlight to form silver, which is solid, and chlorine, which is gaseous. So this is the example of photochemical decomposition. So 2 टाइप का डिकम्पोजिशन रिएक्शन है, एक है थर्मल डिकम्पोजिशन, एक है photochemical decomposition. We are showing both example. One is ferrous sulfate, which will, when ferrous sulfate को आप लोग अगर हीट करेंगे तो इसमें 3 simpler compound form होगा. One is ferric oxide, another is SO2, other one is SO3. Similarly, हम लोग और एक एग्जाम्पल ले रहे हैं जो फोटोकेमिकल डिकम्पोजिशन का, वेर इन सिल्वर क्लोराइड और सॉलिड है इन नेचर, इन प्रेजेंस ऑफ सनलाइट विल फॉर्म 2 simpler component, silver which is solid and chlorine which is gaseous. Next, we are coming in displacement reaction. This is a very important. This is displacement reaction. What is the definition? A chemical reaction in which an element or radical has replaced another element in a compound. आप लोग ये देखिए, in a chemical reaction, there are two reactants here, iron and copper sulfate. Here, what is happening in the reactant? Iron is replaced copper from copper sulfate to form FeSO4, and copper will be displaced by iron to form copper solid. Right. So here, iron, copper is being displaced by iron. Why the copper is being displaced by iron? Because iron is more reactive than copper. When we discuss in activity series in another session, we will see that in activity series, iron is coming before the copper. So iron is reactive, more reactive than copper. So it will displace the copper from any compound of copper, and it will form the copper solid. So what we are learning here, in activity series, the reactive component should come first, and less reactive component will come in below. The reactive component will displace the less reactive component from its compound on any salt to form the corresponding salt and the corresponding solid of less reactive component. Here iron is more reactive than copper, so it will displace the copper from copper sulfate to form ferrous sulfate and copper solid. So this is the example of the displacement reaction. We should write here another equation, that is zinc plus copper sulfate. It will form zinc sulfate plus copper. Zinc here more reactive than copper. What we have discussed in earlier slide, whatever the element which is more reactive than any other component, it will displace that particular component from its compound or from its salt to form the corresponding salt. Here zinc is more reactive than copper, so zinc will displace copper from copper sulfate to form zinc and copper solid. Another equation, lead plus copper sulfate. It will form PbSO4 plus Cu. Here also, lead is more reactive than copper, so it will form lead sulfate. It will displace the copper to form the lead sulfate. So what we learn from the displacement reaction, the element which is more reactive than another element, it will displace the less reactive element from its salt or compound to form the corresponding salt or compound. So these are the example of the displacement reaction. Next, we are coming from double displacement reaction. What is the definition? A chemical reaction in which both reactants are decomposed to give two new compounds by exchanging their radicals. You should follow the both reactants should decompose to give two new compounds by exchanging their radicals. In sodium sulfate, sodium is the radical. In barium chloride, barium is the radical. What happened in product? From sodium sulfate, sodium will be replaced by barium to form barium sulfate, and from barium chloride, where barium will be replaced by sodium to form sodium chloride. So this is nothing but the example of the double displacement reaction. Here both the reaction will decompose to form two new compounds by exchanging their radicals. Here sodium is being replaced by barium, vice versa, barium is being replaced by sodium. So this is the example of the double displacement reaction. Now we are coming the oxidation reduction reaction. An oxidation reduction reaction where in a substance gain oxygen or loses hydrogen during a reaction. It is oxidized. Just go through the definition. Wherein a substance gain oxygen or loses hydrogen during a reaction, it is oxidized. If a substance loses oxygen or gains hydrogen during a reaction, it is reduced. Here, copper oxide reacts with hydrogen to form copper and water. Here, copper oxide loses oxygen to form copper. That is, copper oxide is being reduced. Hydrogen gain oxygen to form water. So as per definition, hydrogen is being oxidized during the reaction to form water. So by definition, it is saying that copper oxide loses oxygen during a reaction. So copper oxide is being reduced during this reaction to form copper. Hydrogen gains oxygen during this reaction to form water. So hydrogen is being oxidized during this reaction. We should go for some other example. Zinc oxide plus carbon, zinc plus carbon monoxide. Where zinc oxide similarly loses oxygen to form zinc. So here zinc oxide is being reduced as per definition. Carbon is gaining oxygen to form carbon monoxide. As per definition, carbon is being oxidized to form carbon monoxide. So again, we are going to the definition of oxidation reduction reaction. It's a very, very important reaction. It is occurring in our everyday life. It is effective in our everyday life. Wherein a substance gains oxygen or loses hydrogen during a reaction is called oxidized. If a substance loses oxygen or gains hydrogen during a reaction is called reduced. And then this reaction is called the oxidation reduction reaction, where one reactant is being reduced and another reactant will be oxidized. In our first example, as per definition, copper oxide, here we are seeing that copper oxide loses oxygen to form copper. So as per definition, whenever a component will lose oxygen, it will be reduced. Then we will say that copper oxide is being reduced to form copper. On the contrary, as per definition, if a substance gains oxygen or loses hydrogen during a reaction is called oxidized. Here hydrogen is gaining oxygen during a reaction to form water. So here hydrogen, we may tell that hydrogen is oxidized to form water. Similarly, zinc oxide is being reduced to zinc and carbon is being oxidized to form carbon. Another example of oxidation reduction reaction is already we have mentioned, that is MnO2 plus 4HCl, MnCl2 plus H2 plus Cl. So these are the main example of oxidation reduction reaction, but there are various examples of various important example of the oxidation reaction. Now, we should see some effect of oxidation reaction in our environment. One of the main topics is corrosion. We should just shortly, briefly describe the corrosion. When a metal is attacked by substance around it, such as moisture, acid, etc., it is said to be corrode, and this process is called corrosion. In moisture, oxygen is there. Any metal will be attacked by the oxygen, so it will be oxidized to form the new component, that is oxide. So then the properties of the metal will be changed, because we know in chemical reaction the properties of the product will be totally different from the reactant. So if any metal is oxidized in presence of moisture in the environment, it will form its corresponding oxide. So the metal will be converted to its corresponding oxide. So the properties will be changed. So it is called the metal will be corroded. So to prevent the corrosion, what will happen? We should keep the metal in inert atmosphere. So in our surrounding environment, we see our corrosion causes damage to car bodies, bridges, iron railing, ships, to all subjects made of metals, especially those of iron. So corrosion of iron is a serious problem. To protect the iron or metal from corrosion, we should take a steps so that the metal should not मेटल को एनवायरनमेंट का साथ संपर्क में आना नहीं चाहिए. It should be separated. It should not be contaminated with the moisture of the environment. So ऐसा हम लोग को कुछ सोचना चाहिए, जैसे मेटल को एनवायरनमेंट का कांटेक्ट में आना नहीं चाहिए. We should take a step so that metal will not be contacted with the environment. So हम लोग पेंटिंग करते हैं, हम लोग कुछ कोटिंग लगाते हैं, so that this coating, when we will coat the iron by a paint, by any other coating, so it will not contacted with the environment, it will not contacted with the moisture, so it will not be oxidized, so corrosion will not be happening. So we should every year there is a we should there is an enormous amount of money spent to replace the damaged iron. So we should avoid this expenditure by properly maintaining an atom, by applying the proper coating on the particular metal, so that it will not be contacted with the moisture of the environment and it will not be oxidized, so that metal will be protected. So by that way we should protect the iron as well as other metal also. So corrosion is nothing but the oxidation reduction reaction. So by that way, this is the example of the oxidation reaction or effect of the oxidation reaction, and we should take a positive steps to prevent the metal from corrosion or by occurring the oxidation reduction, so that the metal should not be converted to its oxide by contacting with the moisture in the environment. Next, density. Similarly, when fats and oils are oxidized, they become dense. How it will be oxidized? When it will contaminated with the moisture, but it will contacted with the environment, the moisture will react with the fats and oils, and the fat and oils will be oxidized, and it will, in due course of time, it will be rancid. So ये खाने का योग्य नहीं रहेगा अगर वो rancid हो जाएगा. So for that reason, manufacturers are usually, chips manufacturer low usually use the fast bags of chips with gas such as nitrogen to prevent the chips from getting oxidized. अगर हम लोग नाइट्रोजन एनवायरनमेंट में रखेंगे तो मॉइस्चर नहीं आ पाएगा क्योंकि नाइट्रोजन इज ए वेरी इनर्ट एटमॉस्फेयर. तो एयर उसके साथ कॉन्टेमिनेटेड नहीं होगा. अगर एयर नहीं आएगा तो चिप्स जो है वो मॉइस्चर के साथ जो हमारा फैट्स एंड ऑयल्स है वो भी मॉइस्चर के साथ कांटेक्ट में नहीं आएगा. तो इट विल नॉट बीइंग ऑक्सीडाइज एंड वी शुड कीप दिस टाइप ऑफ फूड for a very long time. So rancidity is one of the example of the oxidation reduction reaction, and we should avoid the fats, oils, and other food products to be contaminated with moisture or should not be contacted with the atmospheric oxygen. So these are the effect of oxidation reduction reaction. So this is the topic, friend and student. We are elaborately discuss the chemical reaction indication on behalf of silicon cases, and I think it will be, I have gave various valuable information about the topics. If there are any queries, you should contact through email and we'll reply immediately for any queries whatever we have discussed in the topics. Thank you very much.